Hello everyone, this is Nicole Armand, and we are going to complete our Chapter 5 Integers Foldable by finishing it with multiplication and division. So let's get going on that. We'll keep our number line here, and we will open our book and go to multiplication and division. Although division is going to be a kind of like the same thing that it was when we were doing the whole numbers or the natural numbers. We're going to gloss over division a little bit and call it the inverse of multiplication, although we will have some procedures for it. Okay, so then we're starting with multiplication with our chip model, and multiplication is a bit interesting whenever we use the chips. So I'm going to draw a line here, and we're going to talk about having some notes about multiplication. So the sign of the first number means whether we're going to put chips in or take chips out. So let's write that down. So the sign of the first number means put in or take out. And when we're taking stuff out, we might have to fill our workspace or our little square, our bag, if you want to, for lack of a better word, with 0 pairs. So it's kind of the same thing we did when we were doing subtraction, when we had to take away something that wasn't there, we added 0 pairs. So we're going to do the same thing with multiplication. So let's write that down for takeout. For takeout, you go to the drive-thru. And we already know that we can add 0 pairs to any of our problems here and not affect the final outcome of the number, because a 0 pair is itself and its opposite, and they cancel each other out. So I'm just going to write a little note here: as many as needed. And then if the first number is positive, we put in. And if the first number is negative, then we take out. Okay, so let's see how this works. We're going to do our same numbers over here that we have been using, and we're going to start with 3 times 2. So we're going to grab our counters. For the positive numbers, it's quite easy. So remember from multiplication from when we did our natural numbers, this means 3 groups of 2. And since the first number 3 is positive, that means I'm going to put in 3 groups of 2. There's 1 group, there's 2 groups, and there's 3 groups. So the result of our multiplication problem is 6, and it is going to be a positive 6. So let's draw that. So what we're going to do is kind of draw a square. Let me actually divide this into 4 pieces here. So, and I'm going to draw sort of like a little square that we did the same thing when we were working with the base 10 blocks and the chips. So just a little work area. And we're going to put in positive chips because the 2 is positive, 3 groups of 2. So 1, 2, 3, and I'm going to circle them and draw an arrow to indicate that we are putting them in. So put in. Put in. All right, the next problem that we want to do is 3 times -2. Since the first number is positive, we still are going to put in. But our second number is negative. So this is telling us to put in 3 groups of -2. So 1, 2, 3. 3 groups of -2. I have 1, 2, 3, 4, 5, 6, and it is -6. So easy enough. This one was 6. Let's now put in, let me get my pink pen, 3 groups of -2, and I'm going to circle them, and I'm going to indicate that I am putting them in with my arrows. Great. Okay. Fantastic. Now we come to the interesting ones. This time we want to do -3 times 2. And since the sign of the first number is negative, that means we are going to take out. So, okay, I'm going to take out. Well, take out what? I don't have any chips. See, they're all gone. Well, now you and I know that 3 times 2 is 6 and that we're going to need how many 0 pairs we're going to need, but students don't, so, or they may not. So we're just going to start putting in 0 pairs until we think we have enough to take out 3 groups of +2, right? Okay, so let's see if I have enough. There, let me add another. Okay, so suppose we fill our workspace with 0 pairs, and it doesn't matter how many you use, you could add more. And we're going to take out, because of the -3, 3 groups of +2. So 1, 2, 3 groups of -2 are being taken out. Now, are all the chips the same color? No, they aren't. We have 1 0 pair right here that we don't need. So we take that out as well because it cancels. And then we see what we are left with. 1, 2, 3, 4, 5, 6, and that's -6. So let's draw this into our foldable. So this time I'm going to draw a fairly large workspace here because I need to add in all those 0 pairs. Excuse me. So go. So I've filled my workspace with 0 pairs, and I want to take out 3 groups of +2. So I'm going to start looking for my +2s. Here's 1 group, 2 groups, 3 groups, and I'm going to draw my arrows as taking out. These are some extra 0 pairs that I had in my bag that I didn't need. Those cancel. And now we see what we are left with. 1, 2, 3, 4, 5, 6, -6. Let's do the last one. -3 times -2. We're going to take out, because the sign of the first number is negative. All right, we don't have anything to take out, however, because our workspace or our little bag is empty. So we're going to draw our workspace here in the box. All right, so we're going to start putting in 0 pairs until we think we have enough to take out 3 groups of -2. All right, I've filled my workspace with 0 pairs, and move them so you can see the problem. I want to take out 3 groups of -2. So 1, 2, 3 groups of -2. Are all my chips the same color? No, they're not. I have 1 0 pair right here that I can take out because they cancel. And I'm left with 1, 2, 3, 4, 5, 6, +6. So as you can see, we're getting the correct sign of the number without the students knowing what you know, and that is when you multiply 2 negative numbers, you get a positive number. So when you first start using these concrete models, the students don't even need to know that. We're going to put it in the procedures, but we're getting the right answer without having to worry about positive and negative signs, and whether we get a positive or a negative result. So that is very cool that this works, even though we don't talk about things like negative times positive is negative and positive times negative is negative and so on. So let's fill our bag with 0 pairs. And I'm going to take out 3 groups of -2. So 1, 2, 3, and I am taking those out. I have a 0 pair that's extra that I don't need. Those cancel. And I'm left with 1, 2, 3, 4, 5, 6, +6. So very cool. A little bit of a brain bender, but once you get used to the fact that you can add 0 pairs to make any number that you wish, then things start to clear up and you start to see how you can do these models with the chips. So what are we going to say about the division? Well, we're going to draw ourselves a little happy face and we're going to say, hey, we're done with division. You know why? Because division is the opposite or the inverse of multiplication. Da-da-da. So that's fun. All right, so notice that we have filled in all of our addition, subtraction, multiplication, and division for using the counters, the colored chips. Okay, so this is a very concrete model. Now we're going to another less concrete model, the number line. So let me move my chips out of the way. So for multiplication, we have some rules about how to play. So let's write those down over here. Gosh, my pins and my dinosaurs and my cars are getting all, there's not quite enough room on my desk to do this. So, okay, here we go. What about multiplication? Well, and remember that it is the number of groups times the number of elements, right? We could write that over here, I suppose, would be good. Remember, it's groups times elements. Number of groups times number of elements. So of course, we know that 3 times 2 is the same as 2 times 3 because we have the commutative property, but it is not modeled the same way. So be sure that you remember that from our previous lessons. So now we're turning the page back to multiplication, and we're going to remind ourselves that it's the number of groups times the number of elements. Right? And so the sign of the first number is going to tell us which direction to face on the number line. So you recall over here, I always start at 0 facing forward. We're going to do that, but if the sign of the first number that we multiply is negative, then we're going to turn around and face the other way. So let's write that down. The sign of the first number tells which direction to face, and then the sign of the second number tells us whether to go forward or in reverse. Okay, so the sign of the second number tells us forward or reverse. Okay, so let's get out our little dinosaur and our number line. So we have 3 times 2 that we want to do the first time. This one is fairly straightforward because we're going to start out at 0 facing forward, and so 3 times 2, which I would like to write in pencil so that I can erase it and do it again. Here's pencil. Very good. So we're at first doing 3 times 2. And so our dinosaur is going to hop this time 3 groups of 2. So 1, 2, 3. He's facing forward because the first number is positive, and he's moving forward because the second number is positive. So 1, 2, 3, and he ends up at 6. So that one is fairly straightforward in what we learned before in previous lessons. Now I have to find an eraser, and that might be considerably harder. Let's just have to use this one. Okay, so let's represent that in our foldable. Let's draw our number line. And we know that we are going to be taking 3 hops of positive 2. So 2, 2, 2. We end up at 6. So we were facing forward. Face forward. And going forward. Because both of our numbers were positive. Okay, how about 3 times negative 2? So 3 times negative 2. Here's our little dinosaur, okay. And so since the first number is positive, he is facing forward, and we are going to hop 3 groups of negative 2. Since the second number is negative, that means that my dinosaur is going to go in reverse. 1, 2, need another. 3 groups of negative 2. So I end up with 1, 2, 3. He ends up at negative 6. Okay, let's put that in the foldable. So for this problem, we were facing forward. But going backward. Because the second number was negative. So 1, 2, 3, negative 6. Good. Now let's model negative 3 times positive 2. There we go. Negative 3 times positive 2. Okay, so we start at 0 facing forward, but we look and we see that the first number is negative. So that means that we turn around and face the other direction. Now we're hopping 3 groups of 2, positive 2. So that means that we go forward in the direction that he is facing. So even though, technically speaking, he is facing backward, he is still going to move forward on the number line 3 groups of 2. So we took care of the negative by having the dinosaur turn around. So 1, 2, 3, and he ends up at negative 6. All right, let's model that on the number line. It's going to look just like the other one, which is why I is using this dinosaur. I'm going to have to hope that the grandchildren don't find out that I swiped it whenever they come over this weekend. All right, so 1, 2, 3, -6. And this time though, we were facing backward and going forward. There we go. Okay, so the last problem we need to model is -3 times -2. Numbers in parentheses. Okay, -3 times -2. -3 times -2. Okay, our dinosaur starts out at 0 facing forward, but we look at our first number and we see that it is negative, and that means that he is supposed to turn around. Very good. Okay, and now we see that the second number is also negative, so that means that he is going to move backward. So backward, 3 groups of 2. 1, 2, 3. And here he is at +6. 1, 2, 3. Again, notice that we are getting the right answer without students knowing that when we multiply 2 negatives, we get a positive. So very cool. On the number line, it looks just like the first problem when we actually draw it out, except we know that when we modeled this, that we were facing backward and that we are going backward. So 2 backwards makes forward, right? Okay, so this time 1, 2, 3, +6. Okay, what are we going to do about division? Well, we're going to indicate in our notes that division is the same idea as multiplication. That it is the inverse operation. And there is a video that you can go and watch. Video is on YouTube. And the name of the video is Dividing Integers Using a Number Line. By KT and SS. Okay. So we kind of, we didn't really label these. I guess we could grab as far as like this is addition. This one is subtraction. This one is multiplication, and this one is division. Okay, now let's go to the procedures tab And all we have on this facing page is the law of trichotomy. We're going to have some notes for multiplication. And division. Okay. So first, let's get the formal definition for when we multiply integers, and then we will make a little chart that helps us remember what we already know, because we know how to multiply integers without concrete models. And that is if n and n, not the wrapper or the candy, m and n are integers, then m times n means that we are repeating addition, and we are doing this n times. On the other hand, negative n times n is negative n plus n plus n. Also n times. Okay, so what do we know about multiplying and dividing positives and negatives? Let's make ourselves a little chart here. Draw a double line here to indicate that that part is the result. So if I multiply a positive and a negative, my result is going to be negative. If I multiply a negative and a positive, then I am going to get a negative. If I multiply two negatives, and this shouldn't have the double line, this should be a straight line. So if I multiply two negatives, then I get a positive. So if you can remember that this looks like a tic-tac-toe board, and that we have the positives on this diagonal. Positive times positive equals positive, two negatives is positive, two negatives is positives, and so on. And this can help students remember how to multiply integers and how to get the correct sign. It is the same for division, right? So let's formally define division. If A, B, and C, we're going to do it in terms of the inverse of multiplication, just like we did when we first started with the counting numbers. So if A, B, and C are integers with B not equal to 0 because we can't divide by 0, then A divided by B equals C IFF, there's that word again. It means if and only if A equals B times C. So we define our division in terms of the inverse of multiplication, just like we did for subtraction, like we did the very first foldable that we made with the operations on whole numbers. Okay, so that should complete this foldable for chapter 5, which means that we will be able to spend time in class practicing with the number lines and the models. We have chips and we have number lines, not chips that you eat, you know, the counters. And we have some cars that are much cooler than this one. This one is apparently this is a locksmith's van. So, you know, if you need Papa Lock, then I guess this guy can come along and help you. So we have some number lines and we have some cars for you to play with in class. They are much cooler than this one. Hide that one from my grandson and hide the dinosaur from my granddaughter. And that finishes the Integers Foldable, chapter 5. Okay, I will see you in class. And I'm about to send you an email that's going to tell you that you need to watch some videos. So otherwise, have a great weekend. See you next week.